Well, Matt, this is very interesting because when we think about dams, we more or less think about the lake that they're holding back, the water. But you, as an engineer of dams, think of the much bigger picture. So what do you have here to help us learn and understand, I'll say, the process of designing a dam, and all of that is taken into consideration within that watershed?
What I think I'll do today is we can talk about really how we ended up with a dam such as Home Quarry.
Okay.
We'll start talking about the big picture, I guess, the Natural Resources Conservation Service,
Yes.
national efforts down to Virginia, and ultimately how we really got down to the process of putting Home Quarry in. Because the story of Home Quarry is going to be basically the same story for the other 12,000 structures that NRCS has assisted local sponsors with over the past 75 years.
And those 12,000 are nationwide, not
They
just
are
in Virginia.
nationwide.
Yes.
Yes, in Virginia we've assisted with 150 since
That's
about
amazing.
1954.
Yeah, I understand there's only one natural lake in Virginia.
Yeah, I believe it's Mountain Lake.
Yeah, well, exciting. The rest are all from the dams. Well, tell us about, how do you go about determining where a dam is? Where do you start?
Well, where you're going to start is really with an analysis of the watershed and the problems that you have there. And you're going to try and find the best location, I guess, to solve the problem. And that involves a pretty detailed planning process.
And the problem is flooding further downstream, having erratic water flows, things like that.
Yes.
Okay. So we've got a map with pretty colors on
Yeah,
it
so
here.
what we've got here is a map that shows really what we're calling the major watersheds in Virginia. Things most people are readily familiar with. The James River across the middle of the state, that's probably the biggest major watershed in the state. And what we're going to focus in on today for the Home Quarry project is the Potomac River watershed.
And that's in
in
pink
this
there.
color,
Yeah.
in pink up across here. So really just to start at the beginning, the Small Watershed Program in NRCS is set up to assist local sponsors with financial and technical assistance to solve their local agriculture-related flooding issues, sedimentation issues, and water supply issues.
Which is so important for our farmers.
And so really the story with Home Quarry started in 1936 when the department was authorized to provide some planning studies and quite a few major watersheds across the country to identify the flooding issues.
Interesting.
And so that process got started, and there were a lot of studies that were done throughout the time.
Yes.
And looking at the Potomac River. They developed a plan for fixing some of the identified problems.
Okay, so what's our next step here?
So then the next step is, beginning in 1944, Public Law 534 actually authorized the doing some work to actually solve the problems that were identified in the plan. And so part of that process was locally identified problems in Rockingham and Augusta County with the lower North River watershed.
So where is this area? Give it to me
We're
by
talking,
city.
Yep, Harrisonburg.
Okay.
It's Harrisonburg pretty much borders it on the west end, and then extends somewhat over into a little bit of Augusta County there. But that's really where it's centered around.
Okay.
And the local sponsors of this project requested assistance from the Soil Conservation Service in the early 60s. And the local sponsors, as you saw in the video, is the Shenandoah Valley Soil and Water Conservation District.
Okay. So, and from there it went to, a group came in and started studying the site, and what did they determine?
Well, they went through a rather detailed planning process, developed a watershed work plan where they documented the problem, the flooding issues that were there. They identified where the major issues were. This document, the planning document, would have identified what the potential alternatives were, the solutions, the economics behind it. And ultimately, what came out of the planning process in 1963 was a recommendation to construct 15 watershed dams in this watershed.
Oh my, that's a
So
lot.
that was the original plan to solve everything.
That's amazing.
And so I guess the
Next step?
next step would have been, after the 60s, was to get into the actual implementation and design of these projects, which brings us down to the actual Home Quarry watershed.
So what is a watershed? I mean, we're looking at a map with a lot of colors and ridges
Yep.
and shades and such.
So really what the simple definition of a watershed is, it's a geographic area in which every drop of precipitation that falls is going to go to a common waterway.
Okay.
And everything's going to travel from the vertex of the V down to the large opening.
Yes.
And so water does flow downhill,
It does.
which makes things relatively easy as you start looking at this. But the overall watershed for the Home Quarry Dam, I think, is somewhere around 5,000 acres.
Oh my.
You compare that to the overall lower North River watershed at about 200,000 acres. So
Good gracious.
you're controlling a small portion of it, but you can have a significant impact.
It's a cute little dam, huh? Yes. But the big impact that it has is to control the flow and to protect folks downstream.
Yes, what a dam does, what a flood control dam does, is it's going to store the water and let it out at a slower rate over a period of days.
Fantastic.
And by doing that, you can cut the peak flow downstream.
You can control it. So let's see what our next step is. So the dam itself is constructed. You've done your calculations. You've determined the high size of the dam. And we've got about 1 minute left to talk further about the dam. How many gallons or how many acres is needed to create a larger dam? I mean, how do you size it?
Well, the size is all dependent on how tall you can make the dam and how much volume you need to store. So there's a lot of computations that are going to go into this. But typically, as you're looking at siting this, you're going to want it in a narrow part of the valley. You want to really try to get as much water storage as you can with as small of a structure as you can.
Briefly, can you very briefly explain to us how a dam operates? Like, what is this structure right here?
That's going to be the principal spillway. That's going to set the water elevation and allow the base flow to travel through the dam and the principal spillway pipe.
So my understanding, correct me if I'm wrong, is if this is our principal spillway in case the dam water goes high, it's lower than the actual height of the dam wall. And so the pipe goes through that dam. But then what's this spillway over here?
The auxiliary spillway it's a bypass for higher flows, higher volumes of water, so the water safely flows around the dam and doesn't flow over your embankment and potentially damage the embankment.
Yeah, well, that's great. Dams not only protect downstream, but to wrap it up, they're also recreational components in a community too, correct?
Very much so. Everybody likes a water feature, I guess.
Yes.
They're very popular.
It's fun to go fishing in or just walk around.
Yes.
So dams have many purposes, and I thank you for sharing the explanation of how they're determined, where they're determined, and just a little bit about their function. So thank you, Matt, for being with us.
Thank you for having me.